Huxaflux supplies sensors to measure heat transfer and thermal quantities. Our product lines include solar radiation, heat flux, and thermal conductivity. This video explains what a pyranometer does and how it works. A pyranometer measures solar radiation in watts per square meter. Solar radiation is a source of energy. The energy flux is expressed in watts per square meter. It includes visible light as well as non-visible parts of the spectrum. Solar radiation can reach you directly or in other ways: filtered by clouds, scattered by the atmosphere, reflected by the ground surface. By definition, a pyranometer has an 180 degrees field of view angle. The solar energy flux varies with the cosine of the angle of incidence of the radiation. Within its view angle, the directional response of a pyranometer should resemble this cosine response. Solar radiation is transmitted by the pyranometer glass dome and is absorbed by a black coating. There, it is converted to heat. The combination of glass and coating creates a sensor with a near-perfect directional response. This combination of glass and coating also has a flat spectral response in the range from 300 to 3000 nanometers. Spectrally flat pyranometers are often preferred because they can be used in horizontal, tilted, and inverted orientations, using the same instrument with the same calibration. Inside pyranometers, you will find a very sensitive temperature difference sensor, a thermopile. A thermopile generates an output signal proportional to the solar irradiance from the black coating to the metal instrument body. Thermopiles do not require any power supply. Calculating the solar irradiance is easy. Just measure the output signal and divide it by the sensitivity of the sensor. Pyranometers are also available with digital outputs. In that case, calculations are performed inside the instrument. To facilitate the choice of instruments, the ISO 9060 standard defines 3 different pyranometer accuracy classes: A, B, and C. The ISO 9060 standard defines specifications and gives specification limits per instrument class. From Class C to B and Class B to A, the achievable accuracy improves with a factor of 2. Class A pyranometers are subjected to elaborate factory testing of directional response and temperature response. Some pyranometers are heated. Heating solves problems with dew and frost deposition. With dew and frost deposited on traditional unheated instruments, you get unreliable data. For example, these red and brown lines for a dew event, or this blue line for a frost event. With unheated instruments and a typical autumn month in the Netherlands, you get unreliable data for about 10% of the total time. With heated instruments, this 10% is reduced to just 1%. Some digital pyranometers have internal diagnostics. These provide information such as a calibration record, internal humidity, tilt angle, ventilator status, and heater status. It can tell you when leveling is off or when it is time to recalibrate. Pyranometers should be mounted. Common options are brackets for tube mounting and spring-loaded connections for easy leveling. Interested in measurements with pyranometers? Look at our video, How to Measure Solar Radiation. And if you want to know even more, read our notes on various pyranometer subjects at our website www.huxaflux.com/downloads.